Hello and welcome to this video where we're going to solve a problem from Hacker Earth. This problem is called subsequence queries. So let's start reading this problem, understand it, then after that diving into the code. So the problem says that you are given n strings and q questions. Each question contains two values, x and y. We should print yes if the x string is a subsequence of the white string, or the white string is a subsequence of the x string. Otherwise, we should print no. The problem also explains what is a subsequence. It is a sequence that can be derived from another sequence by deleting some or no elements without changing the order of the remaining elements. The input format of our problem, we will have the first line, two space-separated integers, n, which is the number of strings, and q, which is the number of queries. After that, we will have next n lines, in which we will have n strings. And after that, we will have in the next q lines, we will have our queries. Each query will be composed of two space-separated integers, x and y. X will be the number of the first string, and y the number of the second string. For example, that will be the first string and the third string, and we should check if either one of them is subsequence of the other or not. We should print the answer to each question in a new line. And these are the constraints of our problem. We should also take account of the time limit. A small explanation with some examples of the problem. We have ACD is a subsequence of ABCD because we have the A, then the C, then the D in the same order of this string. We have ACD is not a subsequence of BECF or vice versa. As you can see, the A doesn't even exist here, and the B doesn't even exist here. AD is a subsequence of ABCD, as we have A and D on the same order. The same thing here, AD is also a subsequence of ACD. So after reading the problem, we can take a look at an example to know how we're going to solve it. So let's say we have two strings, ABCD and AC, and we want to know if this one is a substring of this one, or this one is a substring of this one. Now, first thing that we should know that the longest string cannot be a subsequence of the shortest one. This will help us in the problem so that we don't check twice. We only check once. We only check if the shortest one is a substring of the longest one. In that case, we can, for example, start by a two-pointer approach. For example, let's initialize the first pointer, G, the second pointer, I. Both of pointers will be initialized at the beginning of each string. So one way to solve the problem would be to check if the both characters are equal. In that case, A is equal to A, so we move two pointers, both of them. B is not equal to C. We move only the pointer of the longest string to C. C is equal to C. We move both of them. So we move this one to D, and this one will be out of range. Since one of the two pointers is out of range, we're gonna break our loop. Now, how do we know if our shortest string is a subsequence of the longest one? We're gonna just check if our I is equal to the length of the shortest one. I was the pointer. It was at index 0, then it has been moved to index 1, then after that it became 2, out of range of our index. So I is equal to 2, and the length of our string is also equal to 2. In that case, this is actually a subsequence of this string. So we're going to print yes. Imagine if instead of A, C, we had A, E. In that case, after checking A with A and moving to B here, we're going to move to E here. B not equal to E, so we move to C. C not equal to E, so we move to D. D not equal to E, so we move our pointer here, and we break from the loop, because G now is equal to the length of the string. Now we're going to check if our I is equal to the length of our string. Actually, I is still pointing to E, so it's still equal to 1, but the length of our string is 2. Since I is not equal to the length of our string, then in that case we're gonna print no, because this string is not a subsequence of this one. Now this will work, but not for this problem, because we will have a large amount of strings, a large amount of queries, and we may have some strings that are very long. In that case, we should take care of the time limit constraint. Imagine that we didn't have any C right here, and we had like 100 other characters, and at the end we had the C right here. With our initial approach, we should check if the C is equal to this character, then this one, then this one, then this one, then all those characters, until we found that is equal actually to C. Wouldn't it be more helpful if we could just jump to that C? This is one of the optimization that we're gonna do to our algorithm to improve our time complexity. But how are we gonna do that? Basically, we're gonna pre-process the positions of our characters in our strings. And to do that, we're gonna create a 3-dimensional array that we can call next to find the next positions of the character. For the first dimension of our next array, there will be the index of our string. Imagine that our long string, ABCD, was the fifth string in our strings list. In that case, we will have 4 here because it's 0 based indexed. So imagine this is the 5th string and this is the index of that string. The second dimension is the index of the position in which we are in our string. Imagine in that case, we found that A is equal to A and we move to B. B is the second position, but because we are 0 indexed, then it's the first index in our long string. Now we are looking for C, of course. So here, we're going to put the character in which we are looking for. We're going to start by A, then B, then C, and all the other lower cases letters of the alphabet. If we set the A letter at 0, then B will be 1. Then in that case, C will be the 2. So the index of C will be 2. So we are looking for the next position of the C character, because this is the 2, starting from the first position in our fourth string. So we are in the fourth string, we are in index 4, position 1, and we are looking for character 2. What is the position? In that case, it may be, for example, 105. I'm just giving a random number. So the position for the next C, starting from position index 1 in our fourth string, is 105. What if instead of looking for C, we are looking for E, and we don't have any other E in our string? In that case, what are we going to put here? Well, by default, if there is no more character in the rest positions of the string, the remaining positions, we're going to put the length of the string here. In that case, for example, imagine the length was 106, so we're going to put 106 if we were looking for E. Of course, E will be, in that case, 4, because A, B, C, D, 4. So E is the 5th letter, so it has index 4. So in this way, that would be easier for us to check what is the next position and to check if the position exists or not. Because if the position is equal to the length of the string, we know that this character doesn't exist, because we know that the characters will go from 0 to the length minus 1. The second optimization that we can do for this problem is to try to save the queries that have a positive result. For example, let's say we have string 1 with 3, and we have this query many times. Another time here, 1, 3, 1, 3, 1, 3. Do we have to check each time if 1 is subsequence of 3 or 3 is subsequence of 1? That wouldn't be helpful. It would be better if we can just save our result and check each time if we already have the result of those queries. On the other hand, we can also check if we have, for example, our inputs, we can also read them in a way more optimized. And this is what we're going to do in our code. So basically, we're going to do 3 kinds of optimization for the code. The first one, will be optimization for finding the character, which is pre-processing the strings. The second one is saving the queries. And the third one will be to try to optimize the input reading. So let's read the code. The code is quite long, and we're going to solve the problem with the C# language. That's why I'm not counting along with the video. So first thing we're going to do, we have some import statement right here, and we have our class solution. And in our class solution, first thing we're going to initialize a strings array where we're going to save all our strings. Next thing, we're going to create our 3D next array that we just talked about it in the explanation. And we're going to create a hash set. We're going to call it cache. And this is where we're going to save our case, our unique case for the queries, just as we said right here. If we found the queries that return yes, we're going to save them in the cache. And we're going to also create our variable n that we're going to store the number of strings. So now we have our first function, which is the main function. The main function in our code, we're going to read the number of string and save it to the variable n. Of course, this function is not built in C# to read inputs. This is a function that we have created to optimize the input reading, and we're going to explain it in just 1 minute. After having the number of strings, we can have the number of queries in the Q variable. Since we have already the number of strings, we can set a size of our strings array. We can also set a size of our first array in our 3D next dimensional array. After that, after having all the inputs that we have, except the queries of course, we can start pre-processing strings. This is a function also that we have created right here. We're gonna try to explain it in just a minute. After pre-processing strings, we're gonna start processing queries. Of course, we're gonna loop through all the queries while I is less than Q, and we're gonna process our queries one by one. Now let's start with the pre-processed strings function. So in this one, we basically have a for loop, and in this for loop, we're gonna loop through all our strings from 0 to n minus 1. And for each string, what we're gonna do, well, we're gonna again read this string. So again, here we are not using a built-in function from C#. We are building our own function to read the input, and we're going to explain it in just 1 minute. This is next function, just optimizing input reading. We're going to put this string that we have read in our strings array based on the index of that string, the first one, the second one, etc. After saving our string, what we're going to do is that we're going to create our 2D arrays. I'm going to put it in our initial first dimension of the next array. So this one, as we said, the first dimension of the next array, it has the index of string, while the second dimension, we will have the position of the character. That's why the size of the second dimension will come from 0 until the length of the string. And this is the third dimension. After that, we're going to initialize our last position array. Last position array will be an array which has a size of 26. Why? Because we have 26 lowercase letter in our alphabet from A to Z, all lowercase. So this is our last position array. And we're going to fill it with the length of our string, the specific string that we set. By default, by default, we're going to assume that the letters are not found on the string. That's why we're going to fill it with the length of the string. After that, we're going to try to update this last position array. That's why we're going to loop through our string, starting from the end of the string to update the last position. So starting from the end until we reach 0. And in last position array, we have our string, and we have the G, which is the position. And of course, we set -a, just as we said here. For example, if you have, for example, let's say C in the ASCII table, imagine that is 35 and A is 33. So 35 minus 33, that would be 2. That's why we always do minus A when dealing with the characters. That would be equal to G. Then after that, we have to update our next array. So the first dimension, as we said, we have the index of the string and we have the G position of the character, and we will clone our last position. So now that we have our last position in our next array, so now we have all the information that we needed, the information that we already talked about here. We have those positions in our next array. What we're going to do, after pre-processing the string, we're going to start processing the queries. So processing the queries, we start by reading the input of next integer, again using this function that we'll create, put it on the x, the same thing for the y, and since this is a 1 index based, we should transform it to 0 index based by doing -1. So if they said we want to compare between the first string and the second string, then that should be 0 index and 1 index. After that, as we already said, we should only check if the shortest string is the subsequence of the longest one. That's why if the string x is longer than y, or they're equal but the x comes after the y, then in that case we should swap them. We swap the x with the y string, so that we always have the shortest one on the x variable and the longest one in the y variable. That's very important. We always have the shortest one on the x variable, the longest one on the y variable. After that, we're going to create our unique k for this query. How to create unique k? We can just multiply the x by the n, the number of strings, then add the y. We know that no two queries can have the same k if they are different. Only similar queries will have the same k. Now we're going to check if the k already exists on the cache. If that's the case, we're going to just print yes and return, because we don't want to check the rest of the code in our function. Of course, we will have this k on the cache because we already added. When we add it right here. If is subsequence is true, is subsequence is a Boolean method that we're gonna dive into a minute. So if it's returned true, we're gonna add the k to the cache and we're gonna print yes. That's why in the next time, if we found the k already in the cache, we're gonna just print yes and return, because we already know that it's a subsequence. Else, we're gonna just print no. Now, to know which is a subsequence or not, well, as we already explained right here, we know that we're gonna use these pointers, but we're gonna also jump characters in the longest string. How is that possible? Well, we initialize our two pointers, let's say position x, position y, both of them at 0. And of course, we're going to set a condition in our while loop. So while our position x is less than the length of the string x and position y is less than the length of our string y, we're going to keep on looping. And what we're going to do, we're going to try to find the next position of our letter that we are looking for, of our character. And for that, we're going to check in our next array that we already built. And we're going to go to the string with the index y, because we are looking in the longest one. And of course, position y, this is the index of the position we are in the longest character, the longest string, sorry. And of course, the third one, that will be the character we are looking for. The character we are looking for, of course, we are looking at character in the shortest one. So x, the position x, and again, minus a, of course. If we are looking for C, then this will be C minus A. If we are looking for E, then this will be E minus A. So if the next position is equal to the string y length, that means that the next position that we found is equal to the length of y. What does that mean? If we remember, that means that the character is not found. In that case, we're going to break the loop. But if it's not the case, we're going to just continue to run to this code. This code is going to increment the pointer on the shortest string by 1, but in the longest string we will not increment it by 1. We're going to jump to the next position plus 1. So in that case, for example, we're going to jump to the next position plus 1, because all those indexes, all those characters are useless. We don't need to check them. And this is the optimization part in our code. At the end, of course, we're going to check if our pointer in the shortest string is equal to the length of our shortest string, just as we said before. And this is what we're going to return. So this is basically the core of our algorithm. The rest is just input optimization. And for input optimization, instead of reading character by character, we're going to create a buffer, which is an array of bytes, so that we can read a certain part of our input stream anytime, at any step. We're going to initialize the buffer size of 0 and the position at 0. And we're going to use them in our readin function. So if the position is greater or equal to the buffer size, that means that we have to refill the buffer size again. How we fill it? By reading. The read function accepts 3 arguments. The buffer, which is the array in which we're going to read. We're going to write our input right here, starting from position 0 and going to the buffer length. Of course, if there is no more input left, then we will not go until the buffer length. We may not fill the whole buffer. And we're going to set the position at 0 to start again, next time from 0. And if the buffer size is equal to 0, in that case here, when we try to fill the buffer, we didn't fill it. That means that there is no input left. And in that case, we're going to just return -1. But in the regular case, before we run out of input, we're going to just return the buffer with the current position, which allows us to return only 1 character at a time. Then after that, we're going to, of course, increment the position, so that next time we return the next character. So this is the read function that we are using in the next and also in the next integer function. The next function, it's for the string. Sorry. So we're creating string builder for better optimization. We're going to use the read function that we created to read only 1 character. If this character is less or equal than 32 in the ASCII table, that means that it's a space or a tab or a new line, then we're going to continue reading. We don't need this character. But if it's greater than 32, then we're going to append it to the SB, the string builder that we created. And we continue reading, and at the end we return, of course, our string. When reading the integer, it will be a little bit different. Again, we're going to use the read function to read 1 character. Again, if it's a space, a tab, a new line or something, just ignore, continue reading. Then after that, if it's greater than 32, we're going to do this line. Actually, after creating our variable 0, we're going to need this line to multiply the x by 10. Then after that, add in the character that we just read, -0. Why -0? Let me just explain this part before explaining why we are multiplying by 10. So just like we did with the character a, because a here is the first lowercase letter, so we did minus a. The same thing we do here. Since 0 is the first integer, then we need to do this. For example, if this is 6, then we need to do the minus operation in the ASCII table to have the right value of the 6 integer. Why we multiply by 10 here? Well, because to get, for example, a digit which is, let's say, 235, and we initialize our x to 0, so in the first iteration right here, we're going to say just 0 multiplied by 10, and we're going to add 2. But next time, when we want to add the 3, then we need to add it as in the second decimal right here. That's why we need to multiply this by 10 to have 20. Then add the 3, 23. Again, in the third iteration, multiply by 10, 230, and add 5, 235. And so this is why we are multiplying by 10 in each iteration. So this is the whole code. I hope you get the solution. And let me try to submit this code and see the result that we will have. Okay, I think I'm having this power problem. Let me submit again. The time limit exceeded shouldn't happen with this code. And as you can see, we are having our solution accepted. I don't know why it says 2 seconds before, but it is actually less than 1 second in that case. Okay, thank you for watching. See you.